we try to solve this numerical example. In this numerical example, what is the here, in order to save the time, already we write the problem. Problem is a solve the following system of equation by Doolittle's methods. Equation is a 3x1 plus 2x2 plus x3 equal 10, 2x1 plus 3x2 plus 2x3 equal 14, x1 plus 2x2 plus 3x3 equal 40. Now, once we check either we write a correct equation or not. So, this one is a 10, 14, 14. So, okay. So, we write a correct equation. Now, how we find the solution? How we find the solution? As we say that, first of all, we write a what? We write a given system of a linear equation in a matrix form. So, what is the matrix form? Here we try to write a matrix form. Here we write a coefficient of A. Now, matrix form of given system of equation. Given system of equation. System of equation. Of equations. Given system of equations. So, what will happen here? Here we write a matrix A is a 3, 2, 1, 2, 3, 2, 1, 2, 3. This one is a matrix A, and here we write a unknowns. How many number of unknowns? x1, x2, 3 unknowns. x1, x2 and x3. This one equal to what? This one equal B. What is the values of a B? 10, 14 and 40. Now, we assume that this one is a value of A, and this one is a X, and this one is a B. Ax equal B. Now, as we discuss, first we factorize the matrix A into a lower triangular matrix and upper triangular matrix. So, here we write what? Here we write A equal LU. Now, for factorization, here we write for factorization or for decomposition, here we write A equal LU, lower triangular matrix and upper triangular matrix. Now, we write the values of A here, and we know that what is the values? Values is a 3, 2, 1, 2, 3, 2. So, first we write the element of a first row. This one is a 3, 2, 1, 3, 2 and 1, 3, 2, 1. Then we write the element of a second row, 2, 3, 2, 2, 3, 2, 2, 3, 2. Now, we write the element of a third row, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, this one equal to what? This one equal lower triangular matrix, and we write the diagonal element of a lower triangular matrix equal to 1 in order to find out a unique solution. So, here we write as we do in a Doolittle's method. So, here we write a 1, 0, 0. Here we write a L21, 1, 0, L31, L32, and here we write a 1. This one is a lower triangular matrix, and we write the diagonal element of a lower triangular matrix equal to 1 into U. Here we write a U11, U12, U13, and here we write a 0 and 0. This one is a U22, U23, and here U32 and U33. So, now how we find the values of unknowns? So, values of unknown, in order to find out the values of unknown, here we multiply row by the column, first row by the first column. So, if we multiply the first row by first column and compare with the element of a matrix A, then what will happen here? Here the matrix A, this one, 3. equal what? First row, this one first row equal to the first column. Then what will happen? This one equal u11. So this implies that what is the value of a u11? u11 equal 3. Similarly, first row by the second column. Then we find the values of a u12 equal what? u12 equal 2. u12 equal 2. Now similarly, first row by the third column, because the values of a lower triangular matrix is a 0 and 0. So when we multiply the first row by the third column, then what will happen? Then u13 become what? u13 become 1. u13 become 1. Now similarly, we multiply the second row by the first column. Then what will happen? Then L21 u11 equal what? Equal to the 2, 2, 2. This one is this element equal to the A12. This one L21 first row, second row, first column. Then this become a, this one equal to the element of a matrix A21. So L21 u11 equal 2. So if we simplify, and if you closely observe this expression, here u11 already we find the values of a u11. So what is the value of a L21? L21 become 2 upon u11, and this one become, what is the value of a u11? u11 is a 3. So this become 2 by 3. Similarly, second row by the second row, so this one is not here, this one is a 0. So if we erase out this one, so this one is a, because here is upper triangular matrix, so here we write a 0, this one is a 0 because this one is upper triangular matrix. So if we multiply the second row by the second column, then what will happen? This become L21 u12 means this row, this column, first element of a second row, first element of a second column, plus u22 equal to what? Equal to 3. Now we put the values of a L21 and u12, because we already find the values of a L21 here in a previous step, and next to the previous step here we find the values of a u12. So what is the value of a u22? Once we simplify this one, then u22 equal 3 minus L21 into u12. So this become 3 minus, what is the value of a L21? L21 is a 2 by 3, and what is the value of a u12? u12 is a 2. So this become, this one is a 2, so this become 3 minus 4 by 3, and this one equal 3 is a 9 minus 4, this become 5 by 3. Now in a similar manner, if we multiply the second row by the third column, then this become L21 u13 plus L32 u23 plus what? Second row by the third column, then this become not L21, sorry, L21 u13 plus u23, and all of the term this one multiplied by this one, then this becomes 0, this one equal what? This one equal 2. Now what is the value of a u23? Because we have a value of a L21, we have also a value of a u13. So u23 become what? u23 become 2 minus L21 into u13. So this become 2 minus, what is the value of a L21? The value of a L21 is a what? 2 by 3, 2 by 3, and what is the value of u13? The value of u13 is a 1. So this become 6 minus, this become 2 by 3, 6 minus 2, this become 4 by 3. So in a similar manner, if we multiply the third row by the first column, then we able to find out the value of L31. Then we multiply the third row by the second column, then we able to find out the values of U22, and once we multiply like this one, then we able to find out all the values of a lower triangular matrix and upper triangular matrix. So in order to save the time, already we write values of a element of a lower triangular matrix and upper triangular matrix. So what are the values? Values with the L21 equal 2 by 3, L31 equal 1 by 3, L32 equal 4 by 5, 3, 2, 1 and 5 by 3, 4 by 3 and 24 by 5. So if we write the lower triangular matrix and upper triangular matrix, because already we find the what? We find the all elements of a lower triangular matrix and upper triangular matrix. Now what is the value of L? Now L become what? L become 1, 1, 0, 0. Then L21 is a 2 by 3, 2 by 3, 0, sorry 1 and 0. L31 is a what? 1 by 3, L32 is a 4 by 5 and this one is a 1, this one is a value of a lower triangular matrix. Now what is the upper triangular matrix? U become U11, what is the value of a U11? 3, U12 with a 2, U13 with a 1 and this becomes 0, 0 because this one is a upper triangular matrix. And now what is the value of a U23? U23 with a U22 with a 5 by 3, U23 with a 4 by 3 and U3, this one is a, here we not write a value of a U22 and this one is a 0 and what is the value of a U33? This become 24 by 15. Now what will happen? We put the values of a LU in a matrix form of a system of a linear equation. Now again we know that what? Ax equal V, Ax equal V and we assume that what? A equal Lu, then Lu x equal B. This implies that again let Ux equal Z, then this equation become what? This equation become, here we put the value of a Ux, this become Lz equal B. Now first we solve the what? First we solve the equation number, this one is a second and this one is a first. So first we solve the equation number 2 because we have a lower triangular matrix, then we have a value of a L and we have a value of a V, we have a value of a L and we have a value of a V. Once we solve this system of a linear equation, then we able to find out the value of a Z. And how many number of unknown in a vector Z? There is a n unknowns. And what are the name of these unknowns? Z1, Z2 up to Zn. So here we may assume that where Z equal this one equal to the number of equation Z1, Z2 up to Zn, but in this case this one is a Z1, Z2, Z3, Z1, Z2, Z3 because there is a 3 number of equation. Now we try to find out the values of unknown Z1, Z2, Z3. So in a Dirichlet's method, first we solve Lz equal B, then we solve Ux equal Z. Now we solve Lz equal B. Now Lz equal B. So here we know that what is the values of L? 1, 0, 0. This one is a value of L. Here once again we 2 by 3, 1, 2 by 3, 1, 0 and here 1 by 3, 4 by 5. 1 by 3, 4 by 5 and 1, and how many number of unknowns in a Z? Z1, Z2 and Z3. This one equal to what? This one equal V, and already we write the values of a B. What is the values of a B? Here. The values of a B is a 10, 14 and 14. So, here we write the values of a 10, 14 and 14. This one is a 10, 14 and 14. Now, we perform the what? We perform the forward substitution. Forward substitution means first we multiply first row by this vector Z1, Z2 and Z3. So, by forward substitution, here we write by forward substitution, forward substitution, we find the values of a Z1. Z1 equal what? Z1 equal, because 1 into Z1, 0 into Z2, 0 into Z3, then Z1 equal 10. Z1 equal 10. Then we multiply second row, then this become 2 by 3 Z1 plus Z2 equal 40. So, here we put the values of a Z1, then this implies that 20 by 3 plus Z1, Z2 equal 14. This implies that Z2 equal 14 minus 20 by 3. So, this become what? Z2 equal 14 3s are 42. 42 minus 20, this become 22 by 3. 22 by 3. Similarly, we find the values of a Z3 by multiplying the third row by this column. This become 1 by 3 Z1 plus 4 by 5 Z2 plus Z3 equal what? Equal to 14. Now, we put the values of a Z1 and Z2. The value of a Z1 is a 10. So, this become 10 by 3 plus 4 by 5 Z2. What is the value of a Z2? Z2 is a 22 by 3 plus Z3 equal what? Equal 40. Now, what is the value of a Z3? Z3 become 14 minus 10 by 3 minus 88 by 15. 88 by 15. So, what is the value of a Z3? Z3 become, now this become 15. So, here we multiply and try to find out the value of a Z3. So, already we noted down the value of a Z3. What is the value of a Z3? Here there is a calculation. So, we find the values of a Z3. Values of a Z3 is a 72 by 15. Already we noted down this value, means in order to save the time, the value of a Z3 is a 72 by 15. Now, what will happen? So, after solving the second equation, now we solve the first equation. Now, again, now we solve what? Ux equal Z. Ux equal Z. Now, what is the values of a U? Here we noted down the values of a U. What is the values of a U? 3 to 1, 3 to 1, 3 to 1, and so if we write in a next page, then it's become very easier, because there is a need to find out the values of x. So, rather than to write here, we write what? We write in a next page. Now, we write in a next page. Now, we solve Ux equal Z. So, what is the values of a U? Here we write the values of a U again. The values of a u is a what? Values of a u is a 3 to 1, 3 to 1, 3 to 1, this one is a 0, this one is a 0. The values of a second row with a what? 5 by 3, 4 by 3, 5 by 3, 5 by 3, 4 by 3, this one is a 0, and last value is a what? Last value is a 24 by 15, 24 by 15, 24 by 15. Now, what is the values of a column vector x? The values of a column vector x is a what? X1, x2 and x3, and this one equal to the z1, z2 and z3. What is the value of a z1? z1 is a 10, this one equal to 10, z2 is a 22 by 3, 22 by 3, and z3 is a what? z3 is a 72 by 15, 72 by 15. Now we perform the what? We perform the back substitution. Now we perform back substitution. Back substitution. Back substitution. Back substitution. So in a back substitution, what will happen? First we multiply the last equation, last row by this column, by this one. So 0 into x1 0, 0 into x2 0, and this becomes 24 by 15, x3 equal what? 72 by 15. So what is the value of x3? The value of x3 become 72 by 15 into 15 by 24. So this one cancel out, this one become 3. So what is the value of x3? The value of x3 become 3. Now we multiply the second row by this equation, this vector x. So this becomes 0 into x1 plus 5 by 3, x2 plus 4 by 3, x3 equal to what? Equal to 22 by 3, 22 by 3. Now we put the values of x3 here 3, then this become what? 5 by 3, x2 plus this become, if we put the value of x3 equal to 3, then 3 cancel out, then this become plus 4 equal 22 by 3, and if we simplify this one, then 5 by 3 x3 equal 22 by 3 minus 4, and this become what? 10 by 3, and what is the value of not a x3, this one is a x2. So what is the value of x2? x2 become 10 by 3 into 3 by 5, this one equal 2. Now we are able to find out the value of x2, x2 equal 2. Now we put the values of we multiply first row by the vector x, and here we write what? 3x1 plus 2x2 plus x3 equal what? Equal 10. This one is a 10, equal to 10. We put the value of x3. The value of x3 is a what? Already we find in a first step. The value of x3 is a 3. The value of x2 is a 2 into what? The value of x2 is a 2. 3x1 equal what? 10. So 2 2 is a 4 plus 3. This becomes 7. 3x1 plus 7 equal 10. So 3x1 equal what? 10 minus 7 equal to 3, and what is the value of x1? x1 equal 1. So what is the answer? Answer become what? x1 equal 1, x2 equal 2, and x3 equal 3. So in the next phase you may write what is the value of x1? x1 equal 1. What is the value of x2? x2 equal 2. The value of x3 is a 3. This one is the answer. This one is the answer. So what is the summary? How we find the solution by the Dolittle's methods. First of all, we write a given system of a linear equation into a matrix form. Once we write a given system of a linear equation into a matrix form, then we decompose the matrix A into a lower triangular matrix and upper triangular matrix by using the Doolittle's methods. In a Doolittle's methods, we write the diagonal element of a lower triangular matrix equal to 1 in order to find out a unique solution. Otherwise, maybe be able to find out an infinite number of a solution. So, once we write a diagonal element of a lower triangular matrix equal to 1, then we find the values of a other element of a lower triangular matrix and upper triangular matrix by multiplying the matrix L and U and comparing with the matrix A. Once we find the values of a lower triangular matrix and upper triangular matrix, then we assume that because we know that Ax equal to B with the system of a linear equation in a matrix form, then we write A equal Lu, then L into U into X become B, we write Ux equal to Z, then the given system of a linear equation become in a Lz equal V. Then we solve a system of a linear equation Lz equal to V, Z with the unknown vector containing the number of unknown equal to the number of equations. So, Lz equal to V, we solve by Lz equal to V. Once we find the values of Z1, Z2, Zn means the unknown of a vector Z, then we put the value of a Z in a equation Ux equal to Z. Once we put the value of a Ux equal to Z, then we solve with the help of a backward substitution and find the values of unknowns x1, x2 and x3. And here one thing I also mention once again means in a Doolittle's method, we write the diagonal element of a lower triangular matrix equal to 1, and in order to find out the values of a Z, we perform the forward substitution, and in order to find out the values of a x1, x2 up to xn from Ux equal to Z, we perform the backward substitution. So, this one is all about this lecture. I hope you enjoy this lecture. So, thank you watching my videos. Thank you.